Hello, ladies and gentlemen. Welcome back to my YouTube channel. Today we will go for vector. Okay, vector we already learned in maths. In maths, we will do slightly more than that. First of all, we need to remember vector is the thing that must have direction and also magnitude. So later you see every time we deal with vector, direction is very important. Today we will cover about the vector geometry, the basic things, for example, the position vector, magnitude of a vector, unit vector, how to count. And also we learn how to compose and resolve velocity by convert scalar to vector, vector to scalar, and how to find the position of a moving object at a specific time, and whether two particles they will collide or not, and what is the distance between them. Let's go to vector. Okay, so first part of the question is very similar to maths. They give us many information about from this point to that point, what is the magnitude and direction. So the question will ask you to find what is the specific vector that they request. They tell us from O go to A, the magnitude is A, OB is B, and then X is the midpoint. So O to X is half of it, so it's half B. And the midpoint of AB is Y, means that this Y is the midpoint of AB. AZ equals to lambda AX, OZ equals to micro OY. So when you see this kind of thing, don't panic. Use based on the request. First question asks you to find what is OZ in terms of AB and lambda. Lambda relationship comes from here, so we must use this relationship. OZ means that we start from O, go to Z. We do not directly know what is OZ, but in vector, we know that we can start from O, go to another position, and then from that position, go back to Z, okay? So this is how we count a vector in maths. They ask us to link with lambda, means that we must link it with this AZ or AX. So the only thing that link with Z is AZ, agree or not? Then here we choose the path of O go to A go to Z. So we go this path. OA is given is A. And then what's AZ? Oh, AZ is lambda AX. Okay, we haven't get what is AX, so we need to find it so we can substitute here. AX is here. So we can actually start from A, go to O, and then from O go to X. You can see we start from A and with X. What is AO? AO is the reverse opposite direction from OA. So make sure you change A to minus A. Because in vector, direction is very important. So what is OX? OX just now we already know is half of OB, which means is half B. So after we know what is our AX, then we can substitute in here. So we know that OZ is A plus lambda minus A plus half B. So how about B? B asks you to find OZ in terms of AB and micro. So micro is here. We can already use this relationship. The only thing that we need to find is what is OY. So OY, we know that it is here. We can actually use O go to A and A go to Y because we already know OA is A. So what is AY? Half of AB, agree or not? So that's why we need to find what is my AY first. AY is half of AB because this Y is the midpoint. AB is A go to O, O go to B. So it's half minus A plus B. So AY is half minus A plus B. A minus half A plus half B, which is half A plus half B. So we get OY, we can substitute in here, half A plus half B. After we deal with this IGCSE question, they like to ask us to continue to solve. Okay, so can you see the next question that they ask us to do is to find lambda and micro, two unknown must have two equations. So part A, they ask us to find what is OZ in terms of lambda. Part B, they ask us to find what is OZ in terms of micro. So OZ equals to OZ. From part 1, we know that A plus lambda B over 2 minus A is OZ. From part B, we know that OZ is micro over 2A plus B. We can actually expand it first, so easier for us to do comparison. So this part A plus lambda over 2B minus lambda A equals to, here also we expand, micro over 2A plus micro over 2B. So after we get this, then we can form two equations by comparing the coefficient of A and coefficient of B. Let's go. First, we're comparing coefficient of A. We have this is A. So what is the coefficient of A? Is actually 1. So we write down 1. So anything else have A? Yes, this is the coefficient of A. Is minus lambda. So left-hand side done. So we go and see right-hand side. This thing have A. So coefficient of A is micro over 2. Successfully formed the first equation. Then second equation, we are comparing coefficient of B. So left-hand side, we have coefficient of B here, which is lambda over 2. So nothing else B on the left. On the right, also, we only have one part, which is coefficient of B, which is micro over 2. Okay, so we successfully formed two equations. So we simplify it and solve simultaneous. So this is my equation 1. This is my equation 2. Then we do simultaneous equation. So I subs in 1 into 2. So 1 minus micro equals to micro over 2. So 1 equals to micro over 2 plus micro. So micro equals to 2 over 3. Then after we get micro, we know what's lambda. Lambda also 2 over 3 according to this relationship. Okay, so we successfully get what is our lambda and micro. Part D asks us to find what is our OZ in terms of A and B only. So we can either subs in this equation or this equation. I subs in here, it looks shorter. Okay, so micro is 2 over 3 divided by 2 A plus B. 1 over 3 A plus B. Done. So this is the complete questions of vector that very common in IGs. We try one more question that's similar to this. Okay, second question, they say Px is this, ask us to find Ox in terms of lambda. So lambda, we must use back the relationship of this Px and Ps. Ox must go through this path, Px. They say Px, we use back Px. So for part A, my Ox, I will use OP plus Px. OP is given as 2A, then Px is given as lambda of Ps. Question do not directly give us what is our Ps. So Ps is PO plus OS. PO we already know is the reverse of OP minus 2A. OS is given as 3B. So this is our PS. Then we substitute in minus 2A plus 3B. All right, so like this, we gain 3 marks. Part B asks us to find OX also. They directly tell us OX is micro of OQ. OQ is here. OS plus SR plus RQ. Then we can directly do. So OS is 3B, SR is 5A. RQ is the reverse of QR, so that's why we must change it to minus B. So at last is 2B plus 5A. So OX is micro 2B plus 5A. Next, they ask us to solve what is our micro and lambda. So we know that part A, they give us OX, part B also give us OX. To solve easier, I expand it first. So 2A minus 2 lambda A plus 3 lambda B equals to 2 micro B plus 5 micro A. Two unknown means we use A to form one equation, B to form one more equation. Left-hand side, the first coefficient of A is 2. Second coefficient of A is minus 2 lambda. So nothing else. So right-hand side, coefficient of A is 5 micro. So we form the first equation. Then B on left-hand side is, on right-hand side is 2 micro. So we know lambda equals to 2 micro over 3. So this is my equation 1, this is my equation 2. Then I subs 1 into 2. 2 minus 2, we subs in this, equals to 5 micro. 2 minus 4 micro over 3. Six over 19 for micro. So after we get micro equals to 6 over 19, then we can get lambda equals to 2 micro over 3. Micro is given 6 over 19. Then it's 4 over 19. So we successfully gain this 4 marks. Okay, so after we successfully gain what is our micro and lambda, so the next question asks us to find what is OX to OQ. It's just 1 mark question. OX to OQ is confirmed came from the relation that I give us. So OX equals to micro OQ. So we arrange by throw my OQ down is micro, and micro is 6/19. Done. We gain this 1 mark. So the last question they ask us about PX to XS. We know that it comes from here. We see back the diagram. So the diagram tells us PX is lambda of PS. Okay, it's this relationship. So we know that PX, this PS, I throw it down, equals to lambda, which is 4/19, which means PX is 4, PS is 19. So do you know what is XS? XS is 19 minus 4, which is 15. XS is 15, PX is 4, 4/15. Just like that. So this vector geometry is just this kind of question. So we'll proceed to the next part. Okay, next part, we go to the basic, include the things that we already learned in maths, which is position vector. When I say position vector of A, it's meaning OA. Second is about magnitude. For example, I say it's the magnitude of OA. It's about the distance. Okay, then we learn how to find the magnitude. Let's say we know this length is A, this length is B. So the hypotenuse is just A squared plus B squared square root of A. And then at last, we'll learn what is the unit vector. This is the new thing that we learn in maths, vector divided by magnitude. Okay, we will see the questions one by one. Okay, so for the first part, we deal with magnitude. Magnitude, we already learned in maths, but can you see in maths, there are something different? In maths, you see something I and J. What is the meaning of I and J? I means that how this object moves left, right. J means how this object moves up, down. So whenever you see IJ, you can also write it in column vector form, which the I will put it up, the J will put it down. I like to write in this way, especially when we need to plus, minus, times, or divide the vector. Okay, so for B, the coefficient of I is 1. For J, the magnitude is -5. So same goes for C is 3 and 11. So for this question, they ask us to find the magnitude of A plus C. We must know what is A plus C first. So A plus C is this plus this. So it's 5, 14. So magnitude of A plus C is just this square plus this square. If you need to know the reason, we know that I means we move left, right. So positive I means go to the right by 5. Positive J means go up by 14. So this is my magnitude. The question requires for exact value, so we write our answer 221. Done. Okay, so the next question is no longer magnitude. They're talking about something called parallel. So let's continue. So we already know IJ means how it moves left, right. So I know my A is this, B is this, C is this. So they say A plus MB. So I count what is my A plus MB first. So it's 2 plus M, 3 minus 5M. And then it tells us this A plus MB is parallel to J. What is the meaning of parallel to J? We know that I is moved left, right. J is moved up, down. So we can confirm this is parallel to J means it's like this. If it moves up, down only, then we can confirm this thing, how much it move left, right. So from beginning to the end, it doesn't move left, right. So we can confirm the I is actually 0. The J will carry a value that I don't know, so I just write 0x. So this is parallel to J. We can confirm I is 0, J I don't know. But from the relationship of I already able to solve what is the value of M. So M is -2. If the question changed to it's parallel to I, if it's parallel to I would be left, right. So and confirm, we don't know how much it moved left, right, but we can confirm it do not move up, down. So this is the relationship that they want you to know if they tell you it's parallel to I or parallel to J. Okay, then we go for unit vector that we do not learn in maths. Okay, so unit vector, as I say, is just the vector divided by the magnitude. So they ask you to find the unit vector in the direction of this. So unit vector is just 40i minus 9j divided by the magnitude. So the magnitude is this. So we get it is over 41, just like that. Okay, one more question about unit vector that says P is this, Q is this. Asks us to find the unit vector for 3P minus 4Q. So we need to know what is 3P minus 4Q first. So my P is 2 minus 5. My Q is 1 minus 3. So it will be, this is my 3P minus 4Q. So unit vector is 2i minus 3j over the magnitude, which is this. Complete. Okay, the next unit vector question. The question asks us to find AB. So we know that AB is actually AO to OB. So AO is the reverse of OA. So everything we change symbol. 6 will become minus 6, minus 5 will become 5. OB is this. So AB is 4, 8. So the unit vector would be 4i plus 8j over 4 squared plus 8 squared, square root of it. Okay. Okay, go to the third part. We need to compose and resolve velocity. In this part, the fundamental thing is you need to know how to convert scalar to vector or vector go back to scalar. In this part, the vector always show in ij to display their direction. There are two situations for you to convert back to vector. First situation is they give you the direction. Second situation is they give you the angle. We see how if they give you direction first. If they give you magnitude and give you direction, so the thing that you need to use is magnitude times unit vector of the direction. Let's see, the magnitude is given as 200. The unit vector of the direction is 7i minus 24j divided by the magnitude. So you get 56i minus 192j. So this is how you get the velocity, which is in vector. Okay, we try one more question. They also give you the magnitude. Okay, even though they say it's velocity, but in MS velocity must be paired with ij or in the column vector form. So here this 20 is just display the magnitude, and then they tell you the direction is this. So again, we use the magnitude times unit vector. Just like that, then we can get what is the velocity vector. Okay, there is one question a bit special in 2022 that says find the vector in the opposite direction to this. So again, they give you direction, they give you magnitude. We apply the formula 8.5. Since they say opposite direction, so instead of 15i, we write negative 15i. Negative 8j, we write as positive 8j because opposite direction. Change symbol only. Okay, just like that. Second situation that they ask you to change from scalar to vector is they give you angle. So when they give you angle, you need to use Staccato to solve it. They say the velocity vector make an angle of 30 with positive x-axis. Okay, we draw it out. So positive x-axis is here. So 30-degree go up is here. Modulus W equals to 2 means that the hypotenuse, the distance, the magnitude of W is 2. So magnitude is always a hypotenuse. They ask you to write it in I and J form. I is always showing you how it moves left, right. So this part is the I, and then J is how you move up, down. So this is the J. We can find our I and J separately. This is hypo, this is adjacent, this is opposite. So to find I is the combination between adjacent and hypo. So we use cos. So cos 30 adjacent over hypo is 2. So the I value is 3. And then J is O and H relationship. We use so. So we can confirm vector is square root 3i plus 1j. Okay, we try one more angle situation. Okay, they say a ship leave a position vector with a relative to O. It deals with the speed of this. Okay, it means that this is the magnitude. So you have magnitude, you have bearing of 120. So confirm we are doing staccato. So we draw the drawing of 120 first. Here is 90, here is 30. Magnitude is 6 3. Magnitude is always a hypotenuse. Then we can find our I and J. So our I is moved left, right. So this is our I, this is our J. Our I is adjacent, this is opposite, this is hypo. So to find I is adjacent over hypo, cos. J is right, so we can confirm velocity vector is 9i and then 3 3j. Here you need to be extra careful. I is showing you move left, right. So the move left, right is always start from the origin. So this I is obviously go to the right. Go to the right is positive because go to the left is negative. This J is move up, down. So this thing is actually below the origin. So we need to put negative here. So like this, we can successfully get what is the velocity vector if they give you angle. Okay, after you know how to convert scalar to vector, then the next thing you need to know is how to find a position after a time t. We always use the formula of initial position plus velocity times time, because velocity times times is actually the distance. So remember, we use this formula. This is the initial position vector for A and B. I write it down first. For A and B, the initial position is 2i 4j, and then for this is 10i 14j. And then they say particle A and B start moving at the same time. A move with a constant velocity of I plus j. So we already have the velocity of A, which is 1i, 1j. And then B move in the constant velocity of -2, -3. So for this question, we don't need to do any conversion because they already give all the information in velocity. So we can already apply the formula for the position vector of A is initial plus VT. Like this, you can get in the first mark. And then the position vector of B after t second is initial position plus VT, just like that. Okay, we try one more question again. So this question is about particle A. So this is particle A have a position vector, means that initial position of A is 3 minus 2. We travel of a speed of 26 with the direction of this. So they do not give you directly what is the V. So we need to find our V. V equals to magnitude times unit vector. So after we get what is our V, the position vector of A after time t is initial plus VT. Done. Okay, then we see a question that's a bit special. The particle start with a position vector of 67 minus 18. And then this is its travel at a speed of 20. Then they tell you the angle is here, and then tangent of alpha is 3 over 4. So if we draw it out, it will be like this, TOA, okay? So this question that do not directly give us what is the angle. So if this is a calculator paper, you can key in calculator to find what is the angle, and then you do as usual. Other than that, you can also use direction method to do. We know that the direction of movement, I go to the right, agree or not? So it's 4i, and then I go up for 3, okay? So this 4, 3 is a direction. It's not exact the value of I and j, because it just show you I will go in this gradient. After we know this is a direction, then we can do speed, which is the magnitude times unit vector of the direction. So we get it is 16i plus 12j. After we know the velocity is 16, 12, we know that initial position is this, then we can know the position after time t is initial position plus velocity times time. Okay, so after we know how to gain the position after a certain time, then we can compare these two objects. If both of them moving, so will they collide? This is the first application. So we go for the first part. It says P is moving with a velocity of this and direction as this. This question give you magnitude and direction, so you need to find the velocity vector yourself, which is after we know the velocity, they say at time t, p has a position vector of this, means that initial position is 1, 2. Then write down the position vector of p after time t, initial plus vt. Okay, so after we know what is the position of p after time t, to know whether two things will collide, we must have another information. So here they give us the information of q. Position vector initially is 17, 18, and then it has a velocity vector of 8, 12. So they directly tell you what is the vector itself. Okay, so we directly use this times t. So after we know the position vector of p and q, if the question says they will collide, means that they will reach a same position. Means that this will equals to this. So if they will collide, means that either their I or their J will be the same. So we can use either I or J to solve them. So if we use the I to solve them, would be 1 plus 12t equals to 17 plus 8t. T is 4. So we know when time is 4, they will collide. And they ask us to know the position vector of point of collision. Means the position that they will collide. So we just sub in our t equals to 4 either into p equation or q equation. Both will give you the same answer because they collide at the same position. So let's say I use this times 4. So it'll be 1 plus 48, 2 plus 64, 49, 66. Fully, you gain this 3 marks. Previous situation, we see whether they will collide, which means their position after time t will be the same. Now we need to know how to find the distance. Front part is everything the same. We need to find what is the position of p and q after time t. Let's go. So they say the particle initially have this position, move in a constant speed with the direction. So we need to find what is the velocity vector, which is 10 times minus 4i plus 3j. Then we can find the position vector after time t, which is the initial plus vt. Then it says as p start moving, a particle's q start to move. So we know that the r of q is okay. This question they want us to find the speed of q, which is very interesting because we know that the velocity of q is 5i plus 12j because initial plus vt. So v is given. So if v is given, 5i means I move in this way 5. 12j means I move up by 12. So can you know what is the speed? We just do hypotenuse, which is, so the speed of q is just 13. Okay, so after we know the position vector after time t for p and q, then the next question asks us to find the distance between them when time is 10. So it will be minus 50 and 70. How about q? Minus 30, 210. So this is the position of p and q after time equals to 10. So then they ask you what is the distance between them. What is the meaning of minus 50, 70? It's actually telling you the coordinate is actually minus 50, 70. How about these? Q is minus 30, 210. That's why we can find the distance. The distance is just the difference of x squared plus difference of y. Then they want exact form, so do not key in calculator to get the decimal. This is the exact distance after time t. So congratulations, you gain 3 marks. So for the distance, it's very easy. It's just like we are doing the coordinate. So the position after time t is just showing you what is the x and y. So you just do as your normal maths. So these are the techniques that you need to learn in vector. So I hope you enjoy the session and learn something. So please help me to subscribe, like, comment, and share my video. Thank you and see you in the next lesson.